Hello, welcome to our next lesson. We are going to be talking about reflections today, which is another form of a transformation. For reflections, I want you to think of a reflection as looking in a mirror. What you see back is a mirror image. So if you raise your right hand in the mirror, it looks like you're raising your left hand. So if you were to flip yourself over, it looks the same, but it's actually a mirror image, so it's not exactly the same. So to flip is the reflection, and I want you guys to remember that because reflection has FL and flip has FL. So to turn over or to reflect is what we're going to be doing today. Our learning target hasn't changed. We want to be able to, given a polygon and a coordinate plane, be able to represent a transformation. Today we're going to be doing reflections. We've already done rotations and translations. Okay, break out your notes. We are going to get through this quickly. A reflection is simply, as we just said, it is flipping a geometric figure over a specified axis. Remember, there's only two axes. There's the x-axis, which is horizontal, and the y-axis, which is vertical. So this is x and this is y. The figure will either be reflected across the x or the y. Remember, we just went over that. Reflections are mirror images of each other. So they look very similar, but there's going to be some aspects that are a little bit different. And really quickly, how do we reflect it? To reflect a figure, count how many units away each point is away from the axis of symmetry. That just simply means which line it's going over. And then you make a new point that is an equal distance on the opposite side of the axis. And then you repeat the process for each point on the figure. It's that simple. So to reflect a shape over both the x and the y, we're going to start by finding the original points. If we look at our original shape, yours is gray, mine's green. So our original shape, if we look at A is at -1, -1. B is this point right here, and it is at -1, -3. They're all going to be negative, negative because we're in the third quadrant. C is at -1, -5. And D is at -3, -3. So now what we're going to do is we're going to first reflect it over the x-axis. And if I take out my trusty highlighter, I like to highlight the axis that we're reflecting over so that you can see how far it is from each point. So to reflect it over the x, we're going to count how many units is A from the axis, the line of symmetry, or the x-axis. It's only 1 unit, so that means we're going to go the same up above. So our new A prime, is going to be at -1, +1. Likewise, we're going to count for B. B is, I'm going to change my, B is 1, 2, 3 units. We're going to go 3 units up. So it is going to be at negative, oh, that's wrong. This should be -2, sorry. -2, the negative, and then a +3. Likewise, we're going to do point C, and it is 1, 2, 3, 4, 5 units. So we're going to go 1, 2, 3, 4, 5. Sorry, I didn't draw point B. So this is B prime, and this will be C prime. We can connect them. And then we only have D left. C prime is going to be at -1, +5. And then D is 1, 2, 3. Exact same point where we're just going to go up 3. So there's our D right here. So we're going to connect it. And we have the exact same shape, but the only difference is the A's are close together. So that's why it's a mirror image. It's not a translation. It looks similar to a translation, especially if your shape is symmetrical like this one. So on this one, we had -3 and a +3. Now, if you look for a second, look at our two examples here. Go back to my yellow. If you look, our -1, our x's have stayed the same. So if you're reflecting over the x, your x values here and here stay the same. What is changing is the y values. And if you look at how they're changing, the number stayed the same. What is changing is the sign. So an easy, quick way, and you can write this down, if you're going over the x-axis, remember we wrote this on our table, you keep the x the same and change the sign of the y. And that's all we did. The numbers actually stayed the same. The only thing that's changing is the sign of the y. So likewise, if we change things up, and I'm going to go ahead and erase this just so you're not confused on this side near the shape, because we're going to be now reflecting over the y-axis. All right, we'll go back, and I'm going to highlight, since we're going over the y-axis, I'm going to highlight the y-axis so you can see where we are drawing the line from. And just like we did for the x-axis, we're now just going to count how far away is the A. The A is 1 unit, so we're going to go exactly 1 unit over. So that is my A prime. My B prime is 2 units, so I'm going to go 2 units. So there's my B prime. My C is 1 unit, C prime. So if we draw our shape, and then our D prime is 1, 2, 3 units from the y-axis. So I'm going to go 1, 2, 3 units, and there's my D prime. So it's that simple. Now, if we were to go back and write down what those coordinates are, if we look, we're at 1, -1 for A. B is at 2, -3. C is at 1, -5. And D is at 3, -3. So if you look now, go back to your original. The original was negative. If you look at D, I have a positive negative because I'm changing the sign just like the x-axis when I went over the x-axis. With the y-axis, if I'm going over the y-axis, you keep the y the same. And guess what you're going to change? You're going to change the x. And that's as simple as reflections are. If you can't remember the rules about keeping the number and sign the same, then you can just simply count from the line of symmetry, or the axis of symmetry. Okay, so let's do one more example. If you flip your page over, we're going to take this trapezoid and we're going to reflect it from the x-axis. So let's highlight our x-axis. That's this one right here. Remember, x is horizontal. Let's start by writing down our original points. So how many blocks is A? 1, 2, 3, 4, 5. So it is a +5 from the x-axis. B is also 5 units from the x-axis. C is, if I go here, 1, 2, 2 units, and D is also 2 units. So now, if I'm going to reflect it over, all I have to do is do the same thing, but in the opposite direction, which means my 5 would be negative on both A and B, and my C would also be negative, and my D would be negative. So then, if we write down our points, our original point was at 3, 5. So our new point, because we're going over the x stays the same, and the sign changes for our y. That's all we're doing. So with B was at 8, 5. So it would be at 8, negative 5. C would be at 4, 2. And when we reflect it, the 4 stays the same, and the sign changes on our y, so it's 4, negative 2. With D, it's 7, 2. Reflect it, 7 stays the same, and the sign changes for our y. And that's as simple as it's going to be. If you don't remember the rules, go back up, and we can draw it. So if this is 1, 2, 3, 4, 5 units, we're going to go on the same line, 5 units down. 1, 2, 3, 4, 5. So there is our A prime. B prime, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B prime, same distance from the other side. C is 2 units, so let's go 2 units. And D is also 2 units. So that's how simple a reflection is. And if you can see, it's a mirror image. That means if this was a mirror, then the image is actually the reverse or a reflection of what it was originally. Okay, the last one I'm going to let you do on your own. I will go ahead and give you the original points. This time you're doing it over. This time you're going to do it over the y. So that means you're going to flip it. So with our rules, the y is going to stay the same and the x is going to change. So your original points are still the same. 3, 5, 8, 5, 4, 2, and 7, 2. And you're going to complete the rest for your homework and answer the questions on Edmodo. Remember, a reflection is just a mirror image, so you're counting equal distance from the line of symmetry or the axis that you're jumping over. So make sure that you're just counting carefully, and that when you're writing your points, you remember you're to walk before you fly, which means you're going on the x-axis before you go up or down on the y-axis. Don't forget to do your homework.